The Streaming Learning Center Bitrate Explorer, or SBE, was built to analyze a single file. But you can't make portfolio-wide decisions based on a single file. So in the new version, we've created a portfolio feature that lets you collect results from multiple source files and perform BD rate and break-even analysis based on all of them. It's a free upgrade to previous versions and available now at this URL. This tutorial will walk you through using the portfolio feature from data entry to Excel exports. First, let's discuss the mental model for a portfolio. Every source clip gets measured once, producing one SBE file, which is a saved project containing all of that clip's encodes and their scores. A portfolio is just a stack of those, one SBE per clip. Inside each clip, the encodes are sorted into groups. Here we've got two, medium and very slow. And this is the one rule you can't get wrong. The group names must match exactly across every clip. If one title says very slow and the other says very _ slow, the portfolio won't line them up and the clip drops out of that comparison. And a group can be anything you want to compare. 2 presets like here, 4 codecs, 5 different ABR ladders. The portfolio doesn't care what's inside the group, it just lines up whatever groups share the same name. There are several ways to create a portfolio. If you're in testing mode, save your different projects into a common folder. And you can multiple select from those projects to create a portfolio. But for longer files with lots of iterations, it can take a while for SBE to compute metrics, particularly VMAF. So, if you want to process multiple files overnight, you can use a downloadable pre-compute utility. As the name suggests, this pre-computes all metrics and stores them in an SBE file you can open in SBE or simply add to a portfolio. To run pre-compute, create a folder, place the source file in that folder, and create separate folders for each group of files. Each folder must be named exactly what you want the group to be called. Here we're comparing the H.264, HEVC, VP9, and AV1 codecs. So long as the folders are identically named for all files, your groups will combine into a single portfolio. If your names don't quite match, don't sweat. You can correct the names in SBE or load the SBE file into a text editor and make the changes there. If you use the pre-compute function, create all your projects in the same folder. Then click Open Portfolio Folder, navigate to that folder, and SBE will add the most recent SBE files in each folder for each file. Save it, and then you can reload it directly. When the portfolio loads, you'll see the SBE application change. The single file tabs go dark, File Intelligence, File Compare, Frame Type, and the rest. The 2 views that remain are BD Rate and Breakeven. This is the BD Rate view. Up top, a metric selector, VMAF, PSNR, or SSIM, and a baseline. This is the group everything else is measured against. The table is the consolidated BD Rate matrix. This measures how much bandwidth the very slow preset saves over the medium preset over all your clips. To compute this, we computed BD Rate for each individual clip and averaged those values. Reading it is simple. Read by row and then by column. The top row is the medium preset. To achieve the same quality as very slow, you'd have to increase the bitrate by 10.42%. Positive numbers are bad, which is why that's in red. Very slow can produce the same quality as medium at a bitrate savings of 9.375. Negative numbers are good, which is why it's in green. Note that you can assign categories to your clips here, and then see category-specific results here. You can view the BD Rate table by baseline, metric, and category. The portfolio BD Rate view doesn't include an RD curve view because there's no mathematically correct way to combine RD curves from different clips into a single RD curve, particularly when the run count differs between the clips. If you want to view the results from any single file, just click it here, and another instance of SBE will open with the RD curves and all tabs working. Finally, here's the break-even view where we convert quality data into hard numbers. There are multiple settings to customize to make the results as accurate as possible for your service. First, choose the baseline, usually the current technology. In this case, it's the medium preset, which will compare to very slow. We see that this saves 5.61% over the medium preset. To translate this into actual savings, enter your cost per gigabyte for distribution. You'll see that very slow saves you 0.0017 cents per hour. This error indicates a very small mismatch between the ladder rungs of the two presets. If the number was much larger, it might impact the results, but at 0.2%, this analysis includes 99.8% of all viewers. To account for encoding costs, enter your cost parameters, either cost per hour if you're running instances in the cloud or on-prem, or cost per minute for cloud encoding. My encoding costs 50 cents per hour, and very slow takes about 4 times longer, or $1.50 more per hour. From there, the break-even math is simple. Divide the $1.50 in increased encoding costs by this savings, and you get 869 hours of viewing to fully recoup the encoding costs. If your files are typically watched more times than that, it makes sense to use very slow. If not, very slow will cost more overall. Over 1 million viewing hours, very slow delivers a net savings of around $1,700. It also boosts quality, but only slightly. Note that the quality delta will reflect the metrics selected in the Bitrate tab, so if you're analyzing with SSIM, you'll see SSIM here. Last but not least, note that savings depend on which ladder rungs your viewers retrieve and play. These numbers reflect the top-heavy distribution, which assumes these rungs and these viewing percentages. Since the viewing is concentrated on top of the ladder, the bitrate savings are the highest. In contrast, the mobile distribution pattern concentrates viewing in the middle rungs. So bandwidth savings will be lower, dropping from 6.5 to 2.78, but the quality increase will be higher. Since both the bitrate delivered and savings dropped, the break-even increased from around 870 hours to 3,309 hours, and the savings over 1 million hours dropped from 1,700 to 452. You can create your own preset to reflect your own distribution patterns. Let's briefly explore the export functions. From the Bitrate export, you get a complete record of all data in all files. Here's the overall summary. Here's the Bitrate matrix for VMAF, PSNR, and SSIM. Here are the category scores for all 3 metrics. Individual clip summaries for Bitrate. Top rung summary data. Raw ladder data from all files. And individual ladders, curves, and Bitrate data for each clip in VMAF, PSNR, and SSIM formats. Genre results for all 3 metrics, and a comparison summary. If you export from the break-even tab, you get a summary report for that configuration, which distribution preset, and all applied parameters, with aggregate scores by category and by source clip. It's a great collection of data for any report that you might have to create, or simply to store the data for later reuse. Overall, the portfolio version helps streaming professionals quantify the advantages that advanced encoding techniques or new codecs can deliver to their services with more accuracy than any other tool. For more information on how to download a trial version, check this URL or the description below.